And let's see, where were we last time? Okay, so again, I'm pulling up Webassign. We were right here. We had done number 5, sketching the parametric equations. And like I said right here, this right here is an indication that you have a circle. Whoa, did I explain why that's the case? It doesn't look like I explained why you get a circle there. Oh well. So let me just do that really quickly. Why you get a circle? It comes from this. So if you take x squared plus y squared, then you're going to get cosine squared plus sine squared. And you know, cosine squared plus sine squared is 1. So really, you have, when you can eliminate the, if you take these two parametric, just these two right here, you can eliminate the t and just come up with an equation in x and y like that. And of course, there's this guy right here as well that adds a complication to it, and we handle it there. Okay, so let's go on. Let's move along to number 6. And it says, at what point does the helix intersect the sphere x squared plus y squared plus z squared equals 10? Okay, does anybody have an idea how we can proceed with this one? If not, that's fine. This sine t is our x, and this is our y, and that's like our z. So if we take these and we plug them into here, so we plug in sine t for x and cosine t for y, and t for z, then we get this. And of course, this is 1. Sine squared plus cosine squared is 1, which we just discussed already. And whoa, t squared is 9, which means that you get t equals 3 and -3 at those two values there. Okay, so I'm going to kind of do it backwards, come over here, work over here. So now we have t equals 3, and you can plug it into, probably plug it into here. Plug it into this one right here. So you have sine 3. It's supposed to be points, so that means we use round. So sine 3, so just plugging in t equals 3 into there. Cosine 3 and 3. Apparently, you're supposed to round your answers to 3 decimal places. And then -3 is going to give you sine, or negative sine 3, cosine 3, and 3, -3. Because the sine of -3 is negative sine 3, and the cosine of -3 is just cosine 3. So we're going to put this in the calculator and make sure that you're in radians mode. Okay, so radians mode. So if it doesn't specify a unit, then it's radians. And so you have, and so probably if you've been using a calculator for the other problems, then it's put it into degree mode. So you need to change that back to radians mode. And I have sine 3 is 0.141, and then cosine 3 is negative 0.9. 90. And then, of course, you just have the 3 right there. And then, so then this is going to be negative 0.141, negative 0.990, and negative 3. Okay, let's see those 2 answers. It looks like the second one has to go first. So you got to put in the negative 0.141. And then the first one. So you got to put that answer in first, and then put that answer in second. Okay, you guys get it? For me, it said mine is correct.
Yeah, it works.
Great. Okay, let's move on to number 7. Find a vector function that represents the curve of intersection of the surfaces. Okay, so here we're supposed to find a vector function that represents it. So they intersect in a curve. So let's go ahead and see if we can work this out. Does anybody have any idea how we can do this one?
Could you start with putting the z on the other side for the surface equation?
Take the surface and put the z on the other side of the equation?
Yeah, so it'd be, what would that be? 1 is equal to xy over z? Or does that not help?
I don't see how that's going to help. Maybe, could you know what this next step would be after doing that? Okay, this is quite complicated. So what you want to do is this cylinder part, that can be written in parametric, also in parametric equation, and that's going to be 3 cosine t, and then y equals 3 sine t. And if you let t range from 0 to 2 pi, you're going to get this right here. So then, if this is x and that's y, then z is x times y. So that's going to be 9 cosine t sine t. And so basically, you're going to end up with r of t equals that, x comma y comma, well, oops. We'll have to put it in vector form. Okay, so 3 cosine t, 3 sine t, and then 9 cosine t sine t, like that. Okay, so I go ahead and put that answer in. They use the vector brackets. Yeah, that problem was kind of tricky. Okay, let's look at number 8. Find a vector function that represents the intersection of the cone and the plane. So the cone z equals the square root of x squared plus y squared, and the plane z equals 3 plus y.
I have a question for number 7.
Yeah, go ahead.
How do we know that we're supposed to use cosine for x is equal to 3 cosine t and then y is equal to 3 sine t?
Because this is a circle.
Okay.
So back here on the very first page, right here, this right here, I kind of give you an idea of how to do circles. So this is just something that you have to sort of memorize, this technique right here for doing circles. And it's the x is usually the r, whatever the radius is, times cosine t, and the y is r sine t.
Okay.
Okay. So just from that.
All right. Thank you.
Sure, you're welcome. Okay, so now number 8. Oh dear. So we want to find the vector function that represents the intersection of this cone and the plane. Any ideas how we can do that?
You can make it equal to the set. Make them equal
to
together. Like the square root part, and then input the set formula 3 plus y into the formula.
Oh, put this one into here.
No, into set.
Oh wait, put that over here.
Yeah.
Excellent. That's really good. Okay, so you put it like that. And then
you take the square to the other side.
Yeah, square both sides.
Mm-hmm.
Okay, so that's 9 plus 6y plus y squared equals, ooh, I like this because the y squareds cancel. Yay. Okay, so then that means we can solve for the y. Do you want to do that?
Yep.
So that's going to be like a parabola, right?
Yeah. Looks like.
Okay, so now the idea is here we have y as a function of x, right? And then we have z as a function of y over here. So y is a function of x and z is a function of y. So if that's the case, what we can do is we can set x equal to the parameter. And then if x is the parameter, then that means y is going to be the parameter t squared minus 9 over 6. So just plugging this t into here. And then we plug in the y right here. So then z is going to be 3 plus all this. So t squared minus 9 over 6. But 3 is 18 over 6. So that means z is going to be t squared, okay, plus 18. So negative 9 plus 18, that's plus 9 over 6. So that looks kind of weird. So then the function is going to be, the vector valued function is, the x is just going to be t, and the y is t squared minus 9 over 6, and the z is t squared plus 9 over 6. Okay, so let's try that answer. Okay, great, that worked for me.